So my guest today for the interview is Helen Byrne from Oxford. Helen, it's really great to have you here, and I appreciate your time. Why don't you introduce yourself?
So thank you for having me to talk to you today, Thomas. So I'm Helen Byrne, as you've said, and I'm a professor of mathematical biology at the University of Oxford. I have a joint appointment between the Maths Institute and Ludwig Cancer Institute.
Oh, this is nice, yeah. So Helen, I know about you and your work for many, many years. And when I started cancer modeling, you were already doing it. So you must have been one of the first people ever doing math oncology. Is this about right?
I think when I started, there were very, very few people. And I guess I was lucky enough to work with Mark Chaplin, who I think was one of the very first people. But it's certainly amazing to see how over the last, 30 or so years, how the field has really taken off. And back then you could count the number of people, keep track of all of the papers that were coming out.
Yeah.
Nowadays, it's just impossible.
I remember there was the ESMTB meeting in Amsterdam. I don't know if you went there in like 1998. And there was one session on cancer modeling with 4 talks, and that was that. Yeah.
Yep, that's about, and now you look and there are whole conferences or even thematic programs.
Oh, right, like
this one
yeah.
here.
Yeah, right.
6 months of mathematical oncology. What could be more enjoyable?
Yes, that's right, yeah.
Yeah.
So what did you get interested into cancer modeling?
Well, in fact, how I first got interested, I went to a conference and I heard Mark Chaplin give a talk on cancer modelling, and I think there he was one talk, not in a special cancer session, and it just really intrigued me that you could actually use maths to model cancer. I mean, I've sort of seen other biological applications, but the application area really interested me. I then got in touch with Mark. We wrote a grant proposal together, which was successful.
So you started with a grant proposal, not with a paper?
Yep.
Yeah, that's good. And then probably cancer modeling ever since, right?
Yes, pretty much. So probably, let's see, over 30 years, possibly.
Yeah.
And I think, I was just very lucky because back at that time when I started looking at modelling tumour growth, one, there weren't very many people. The UK was opening up to multidisciplinary research and funding projects that were sort of maths applied to medicine and biology.
Okay. Yeah.
And so I was lucky in terms of when I was starting out, then there were all those opportunities available and people were trying to build groups in those areas. So I was able to benefit from that.
Very nice, yeah, very good. Now, during your career, you have written like hundreds of papers about cancer. So where do these ideas come from? Do you like focus on something? Do you say, I want to cure ovarian cancer now and write 30 papers on that? Or, so how does this work? How do you find your topics?
I guess we find our topics all over the place. I think when we were starting out and mathematical oncology was a very small field, and I guess our understanding of the underlying biology was also quite different from now. A lot of that work, I think, is sort of foundational in the sense of trying to model the core mechanisms that underpin different stages of tumour growth. So not being, I guess, wedded to a particular type of cancer, but sort of doing the fundamentals, say, of the early phases of avascular tumour growth, nutrient limitation, how do these sort of clusters of tumour cells grow, what sorts of structures do they form, and then looking at other phases, say angiogenesis, vascularization, and building the sort of fundamental models to look at those mechanisms. And then I think as the field, and I guess at the same time, by trying to model those sorts of processes, given that at that stage there weren't existing models, There was also, I guess, as an applied mathematician, when you look at trying to model new systems, then it also throws up, I think, interesting non-standard mathematical equations. So I can probably get interested in lots of different aspects, whether it be a non-standard set of equations that require investigation, whether that's moving boundary problems, which was a lot of what the early work was about. And I guess nowadays, I think as the field matures, as experimentalists become more aware of what modelling can provide, then I think the sorts of models that people are developing are becoming, many models are much more specific, looking down at the details of whether it's glioblastomas or particular types of kidney cancer or whatever it might happen to be.
Yeah. I think this also shows nicely that you are cross-appointed in this Oxford Cancer Institute, right? So maybe this also highlights a little bit your path in this modeling. So maybe you were more systematic, more principal ideas in the beginning, and now maybe you're more specific and also look at more data.
So I think I enjoy working across the breadth. So I am still a mathematician. I still enjoy analysing a system of equations, doing some pencil and paper, some asymptotics.
Yeah.
I still, left to my own devices, that's probably what I would do. But I also enjoy the challenge of working with a collaborator who has some experiments, some hypotheses, and trying to see how we can work together to do something that will add value. And that it is challenging because you're not quite sure what that's going to look like. And trying to get to the sweet spot where your model is simple enough, but it will still be useful.
Yeah, I think that's an important sweet spot indeed.
It is, and sometimes it just doesn't work, and you know, they could just do the experiments themselves. Then there's no need to write down a model that confirms what they already know. It's trying to find where you can, I think, add value, and I guess that could be in terms of providing insight, or at the other end of the spectrum, novel equations that are mathematically interesting. I guess the double sweet spot is if you can do the two of those things together.
Yes, right, yeah. Yeah, very nice. Now, I know you have two wonderful kids, so I think during the development of your career, you were a mother, right? And so
I still am.
And you still are.
Yes.
So would you maybe tell us a little bit about particular challenges in your situation?
Every parent, not just mothers, I think it's difficult when you have young kids. You are still working. Often that coincides with when you're still trying to establish your career. There is a tension between spending time with your kids, they're only young for a short period of time, and then sort of making sure that you're continuing to publish, to write your grant proposals. And I guess for probably 10 years or so, you're just in a bit of a haze, and you feel like, or I felt like, you're not doing anything properly. Everything is, you're compromising, you're not spending enough time with your kids, and then you're not spending enough time doing your work, but you get through it.
Yeah, so would you be able to, how should I say, so were there certain people who were important in this part of your career who like encouraged you or enabled you to be successful?
I think probably the people I should most thank are my husband and my mum and my in-laws, because they were the ones who enabled me to attend conferences.
Yeah, of course.
So that I could continue to be develop my career. I think, whatever, 30 years ago, 25 years ago, in terms of role models, I don't think there were that many there.
Probably not, yeah. And supportive colleagues or so?
Yes, I think supportive colleagues to some extent, but I think it was difficult because there weren't sort of such clear strategies as there are now about equality and diversity, taking maternity leave, gradual return to work. And so I think nowadays things have moved on quite a lot. And in terms of part-time working, not having to be working when you're on maternity leave. I mean, nobody has to work, but I mean, I think I did, which I wouldn't necessarily recommend.
Yeah.
I chose to do that because nobody says you shouldn't be doing that. So I think that things have improved tremendously. There's still room for more improvement. And I think colleagues are a lot more understanding. And what I think is lovely is when I see my male colleagues taking their paternity leave and spending time at home with their kids and sort of understanding what that feels like. And I think once we get to a stage of parity, that where it doesn't matter which parent stays at home.
Yeah, I think we have made big changes.
Yes.
Yeah. So.
Yeah.
So would you have particular advice maybe for young female scientists who want to enter research and become a scientist?
You can do it. Believe in yourself. You're as good as the next person.
Yeah, right.
That is what I would say. Possibly even better, actually, than the next person.
Possibly, yeah, exactly.
Yes. Go for it. If you don't try, you won't know. Believe in yourself. And if you, just try. Or what's the worst thing that can happen? Talk to people. If you can sort of see colleagues who've been through, how did they manage to juggle all of the things that you're dealing with? Ask them for their advice and learn from it.
Mm-hmm. Yeah, very nice. Mm-hmm. Let me come back to science. I have one more question, which is the big amount of data which we get from clinical research. We not only get imaging data, we now get genomics data and what kind of omics you have, and data on very different scales play a role. So is this a bit scary for you, or is this an opportunity?
Yes, to both. I think there is an incredible amount of data becoming available, whether that be around, as you said, imaging data, and there are many, many questions. I think looking at each of those different data sets before you start even integrating them, I think there's many open questions in terms of how we mine and analyse and exploit those data to the full, and a challenge on top of trying to actually integrate them together. And I guess probably one of the ways of doing that is around, I guess, multi-scale models, where you've got everything from down to DNA methylation, epigenetics, modelling those dynamics which are happening on certain timescales within an individual cell, signalling pathways all the way through. I mean, and once you can say all of that, but actually integrating the different data sets to do all of that gives me a bit of a headache. But I think that the data is there, and we just sort of chip away at it, and we make contributions to parts of the jigsaw and assemble it together.
Yeah.
But I think even looking at each of those different data sets, they are noisy, they are very high dimensional, they are complex, they can be sparse. You will measure certain things, maybe you've got one tissue biopsy, maybe taken once a year or not very frequently. There's many different timescales, and trying to understand the limitations and or the value that's gained from each of those different types of data set. As I said, I don't think we've kind of got to the bottom of that yet. We don't have to put in 1,000 variables just because someone says there's 1,000 proteins that I can measure. We can be, and I guess that's one of the skills or the advantages of mathematical modelling, is trying to abstract the biology to something that is simple and that's understandable, but that captures the essence of the mechanisms that we're interested in.
Very nice. Yeah. So it sounds like there's still lots for us to do.
I would say
not
so.
just for our generation, but also for the next generation.
Yes, I think there's plenty, loads and loads of really, really exciting mathematical, biological, and medical challenges.
Yeah,
ahead.
I think so too. Yeah. So then, yeah, thank you very much, Helen, for your very nice interview. I'm sure many people will find it very interesting.
No problem, my pleasure.